Hello and welcome back. In example 6.2.2, we'll be evaluating the integral of 1 over 4 plus x squared squared. First thing I want you to know is we don't have one of these square roots. We said our method is usually for things that have a square root in them, but in this case, we could actually apply it if a squared plus x squared is in the denominator. Let me show you how to get started. You could think of this as 4 plus x squared to the 4 halves, and then that's half gives you a square root to the power 4. And so this is the same integral as square root of 4 plus x squared to the power 4 dx. So I'm going to apply the method using the fact that I have this square root now. I'm going to take x is a tan, so a is 2 tan theta, dx is 2 secant square theta d theta. And then the square root is just 2 secant, no squares. And so actually I'm going to need the triangle. If you don't have bounds to start with, you're going to need the triangle to write back in terms of x. All right, so 1 over, and then I have the square root, so I'm going to take 2 secant theta, put it here. And then the dx is 2 secant squared. I end up with 2 over 16. Oh, sorry. I end up with 2 over 16. And then I have secant squared that's left. This looks like a bad integral, but if you remember secant squared, that's cosine. So here I would get 1 over 8 cosine square theta d theta. And now we land in familiar territory. We have an even number of cosines. And so that's going to be 1 over 8. I'm going to use the identity. So that's 1 plus cos 2 theta divided by 2. And then I have, so 1 over 16, integral of 1 d theta, plus integral of cosine 2 theta d theta. And so I end up with 1 over 16 theta plus sine 2 theta. I have a 16 and divided by 2. All right, excellent. Last thing I have to do is I have to rewrite everything in terms of x. Theta is not quite in the triangle, but you can see it here. It's arctan of x over a, or you could solve from it here as you wish. So here I have 1/16 arctan of x over a, so over 2. And then I have 1 over 32, and I have sine of 2 theta. My triangle covers theta, not 2 theta, and so I'm going to need a trig entity. I'm going to need to replace it by sine theta cos theta times 2. Right, so this is the same as this, and I'll end up with 1 over 16 arctan of x on 2 plus 1 over 16. And then sine I can read in the triangle. Sine is opposite over adjacent, so that's x over my square root. And cosine is adjacent over hypotenuse, so that's going to be 2 over the square root. Now let me just simplify here. I mean, that answer is correct, but if we ever ask you to give a simplified answer, what would be nice here is the 2 cancel with the 16, so I get x. And then the 2 square roots come together and the square root disappears. And so this is what I get. All right. So 2 things to learn from this example. First, you don't need a square root. If it's in the denominator, you would apply it this way. And second, in the end, you might end up with something that has 2 theta in it, and in which case you would need to rewrite your answer in terms of the original variable. You would need to use the following identities. So here's the one that we use in this example. And then we have one for cos of 2 theta. It's cosine squared minus sine squared theta.